Hi everybody. Today we are going to start learning section 6.3 and we are talking about exponential functions. So I'm looking in the textbook here. An exponential function is a nonlinear function of the form y equals a times b to the x power. And this is what makes it exponential is because the x is in the exponent. As the independent variable x changes by a constant amount, which means we're going to be adding by a certain amount for our x's, the dependent variable y is multiplied by a constant factor, which means the consecutive y values form a constant ratio. So we're going to look at example 1. Our first step is we're going to identify to see if it's a linear or an exponential function. Remember that a linear function, the y's are going to be adding by a constant amount, whereas exponential function, the y will multiply by a constant amount. So let's look at example 1a. So look at your x's. Your first step is look to see that the x's are increasing by a constant amount, and here they are. They're increasing by 1s. Now look at the y's. The y's go 2 to 4 to 6 to 8. These are adding by 2's each time. So since the y's are adding by a constant amount, that means that this is a linear function. Let's look at letter B. If our x's here, we're going 0, 1, 2, 3. Again, the x's are adding by 1s, but now let's look at the y's. We're going from 4 to 8 to 16 to 32. Our change in our y's is being multiplied by 2. So since our y is being multiplied by 2, this is an exponential function. Let's look at another example like this.
Does each table represent a linear or exponential function? Explain. Part A. As x increases by 2, y also increases by 2. So the rate of change is constant, and the function is linear. Part B. As x increases by 1, y is multiplied by 3. So the function is exponential.
Okay, let's take a look at example 2. So example 2, you're just evaluating exponential functions for a given x value. So for part A, we're given this equation, which is an exponential function because we can see x is in the exponent. We want to evaluate when x is 3. So we're just going to take 3 and plug it into our equation. Remember, follow the order of operations. Do the exponent first. 5 to the third is 125 times negative 2 is negative 250. You could just put it into your calculator and get the answer as well. For part B, we have y equals 3 times 0.5 to the x power. Again, that's an exponential function because x is in the exponent. Let's plug in negative 2. And when I plug in negative 2, again, make sure you follow the order of operations and you get 12, or you can just plug it into your calculator.